ready to get started? Look, here we go. Wait. I won't be able to see it by midnight. All right, here's where we're at. Today is the 25th, is that correct? So we have today starting chapter 6, Tuesday finish chapter 6, Thursday, a week from today, is that correct? Your quiz, 3, over chapters 4 and 6. I am going to make an attempt today to try to make chapter 6 easy for you. I have these little things I'm going to tell you to make sure you write down that should help make it easy. So I think there's a chance that you may want to spend significantly more time preparing for chapter 4's part of that quiz than 6, I think, because after seeing the in-class assignment, I am truly worried about it, of many people, okay, not everybody, but many people, because I don't have you at the point you should be at. But I got to keep going because we already spent 3 lectures on it.
The questions that we'll have on the exam from chapter 4, are they going to be more like the homework or more like the in-class?
Both.
Okay,
the in-class is the easiest you could get.
Right, that's what I'm hoping for.
Yeah, that's right. So if it's like the in-class, it's going to be very easy. But if it's like the homework, that's actually average. It's not even hard.
And then
the PowerPoint would be considered the hard ones, like we went over with the investment portfolio.
Right.
I'd consider that hard. You guys agree with that one?
Yeah, for sure.
Yeah.
And so if that's going to be on the exam, we won't have to worry about that on the final then?
No, not true. Because linear programming is such a fundamental thing for all these other things, you will see linear programming on the quiz and the final.
Okay.
And where you have to look at it and tell me the decision variables, what they are, and define them, the objective function, and the constraints. You're going to see that probably 2 problems on this quiz, and definitely at least 1 on your final. The final one, you know, is definitely not the easy one. It's not the hard one, more like an average, but it's not going to be the easy one. So that will be the 1 question from chapter 4. Like I said, there'll be on the final 1 question from all the previous chapters, except for those last couple chapters we cover, which will be about 40% of your final, those last 2 chapters. All right, so we know where we're at. A week from today, just making sure. All right, we're on the same page. Here we go with chapter 6. Before we get into chapter 6, I want to make sure you realize what these distribution network models ended up eventually turning into. I mean, logistics. Now, if you've ever heard about a job, logistics, that is network models. That is, I mean, it's all about helping a company figure out how to get their goods to their customers the least expensive way possible. And I keep thinking of this company I worked for down in Ohio. They manufactured, I think I've mentioned that before, bathroom stuff, fixtures. And our thing that we would tell all our customers is that, hey, we're one of the few manufacturing companies that you can get a direct order without having to order a whole truckload directly from the manufacturer to your place, which will give you the opportunity then to compete against the big home do-it-yourself type places. Home Depots, the Lowe's, those are the big ones. We sold to them, but we wanted to diversify to the point to where we really focused on those smaller type places. You ever been at, what do they call around here? True Value Hardwares, right? Are those around here, right? Ace Hardware, are those around here? Ace. Those are kind of the smaller do-it-yourself places. And if you're truly someone who goes and shops at these places, you'll realize that at Ace or True Value, the prices are usually significantly higher than if you go to Home Depot or Lowe's, right? But they're so convenient because usually, depending on where you live, an Ace and a True Value might be right around the corner, and a Home Depot might be several miles away.
I don't know.
Well, it depends on where you live. And back, you got to remember, this is back in the 1980s. In the 1980s, the big do-it-yourself places were just starting to take off. It was like before Handy Andy's, you've never heard of them. Forrest, I can't think of the name. Forrest something, who you've never heard of. 84 Lumbers. Even a few of them still around, aren't there? You guys never heard of those either? Before all of those, all there were these little mom and pop do-it-yourself places, the Ace Hardware, the True Values. And they always had to order through distribution centers because the manufacturers, they couldn't order enough to get it directly from the manufacturer. So a lot of companies would send it to a True Value distribution center. And then the True Value stores are franchised, and they're owned by individual people who are paying to call it a True Value. And part of the deal is they can order from the distribution center, which are pretty good prices, then they mark it up. But when the big ones started up here, it was tough for them to compete. And then the company I was with, that was our thing. Hey, we're going to get you set up to compete. We figured out a way to ship directly from us to you and bypass the distribution center. The key is, and this is our logistics person, we had one person, and she was like, we all loved her. She was the best employee, everybody, we knew her value because she was able to make sure, we were one of the few companies that we owned our own trucks. We didn't subcontract this out. We owned our trucks. We owned our warehouse. And she was one of the few people who could make sure that these trucks had a route all planned out, and that the trucks were loaded where the front of the truck was loaded at the last stop, and at the back of the truck would be that truck's first stop. She would have this all planned out in advance, constantly, every single day. A truck knew exactly the route was, they knew exactly what order all the goods were in, and they knew what was there to separate it so they don't accidentally give another order to another customer. And then here is why she became golden. This is the first time, I remember this back in the 1980s. She had the ability and figured out a way, and this is before the internet, to get in contact with enough of companies out in each direction that she figured out how to have our trucks on their way back pick up things that need to get back to Ohio. We were in Mansfield, Ohio. That's where we were located. And so she figured out a way to have these trucks picking up things on the way back. And this was additional profit we never used to have until we had a logistics person. This was a big deal. Logistics wasn't even, most companies didn't even have logistics people yet. And that's what you're about to learn, is this one thing you're learning today is like a whole job out there. And if you embrace this and you find it easy, start looking at, start investigating the different softwares that are used at all these different companies. And if you think this is easy to you, this is a great way to start your career. It's not that hard of a job. If you like this stuff, you can read the outputs no matter which software is being used. You start to learn that, and it leads to a lot of good jobs. So it's a good opening job. As a matter of fact, I did a quick search. I did logistics, and it took me to Indeed. And I just started going down. Granville, Michigan, logistics coordinator. International Trading Solutions in Canton, Michigan, logistics coordinator. Dart Container in Mason, Michigan, import-export coordinator. Manufacturing logistics process coordinator at Fiat in Auburn Hills. I mean, there's just job after job now. It's like, this is a whole career. This one chapter. So, that's my lead-in to get you to at least have a slight interest in this. Are you ready? These are very micro, just so you can get how this is used in real business. 3 models we're going to talk about today are transportation, assignment models, and transshipment. Transportation models are all about when companies have to get goods from their manufacturing or their place to the customers. It's transportation. Everybody hear that? Getting goods from the companies to the customers. Transshipment is almost exactly like transportation models, except if the story talks about that the goods are going to a distribution center first, then to the customers, that's what makes this transshipment. Let me say that one more time, because most students have troubles recognizing as they're being a problem, which one of the 5, you're learning 5 of these, which one should be used. So I'll say it again. Transportation problems are all about getting goods from the company to the customers. But transshipment, the story will talk about how the goods have to go somewhere first, then be shipped to the customers. And usually the story is about a distribution center. Could be something else, but usually it's distribution center. So when it has to stop somewhere, then go to customers, that's when you go, oh, this is transshipment, and start figuring out how to set it up, just like this example. And then if it's just getting goods to a customer, it's transportation. Now here's the difference with assignment. Just like transportation, so much like it that some students accidentally use this for transportation. But the difference is assignment is where it's like one thing is being assigned to one project. It's like a one-on-one relationship. CPA firms will use these because they'll have jobs come in and they have to assign either their lawyers or their CPAs to jobs. And so they'll go through an assignment network to figure out the best assignments based on different things. An example I'm going to show you today, if we have time, a second example, is where a TV station, marketing majors, you're a media person, and you're now at a point where you have to schedule which TV shows for the fall season will be in which time slots. Only one TV show can be scheduled for one time slot. That's how you recognize this assignment. See the difference? I want to make sure you get that. Shipping goods, but to a distribution center or some second place before it gets to customers. And then this is assigning things one to one. There's one project that needs one thing assigned to it. But there's so much similarities between these. The key, I think, and you won't find this on a PowerPoint, is writing down these little hints I'm going to give you to make these fast. As we go, I'll really emphasize this so you know to write it down. Are you ready? Blah, 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 blah. You read all that at home. Blah, blah, blah. All right, here's the first one. This is transportation. You already know in advance, but you can see this company has goods it needs to ship to its customers. Acme Block Company has orders for 80 tons of concrete block at 3 suburban locations as follows. So the 80 tons, 25 of it needs to go to Northwood. That's the customer. We're Acme Block. Our customer Northwood needs 25 tons. Our customer Westwood needs 45, and Eastwood needs 10. So those are our customers. The orders are in. We got to figure out how to get our cement blocks, right? Our concrete blocks to those customers. Where is it coming from? Do we just have one warehouse? Do we have just one manufacturing facility? It says Acme has 2 plants. Each can produce 50 tons. And this is a weekly problem. Each plant can produce 50 tons a week, and the orders that are in for the week are 80 tons. So as you can tell right away, because we have 2 plants, there is a possibility of having the ability to make at least 80 tons, and if we need more, we can make more. 50 is 100, and only had 80s heading out the door. Delivery costs per ton are on the next page, and the question is, how should end-of-the-week shipments be made to fill these orders? This whole thing's about, okay, this plant has 50 tons available. Which customers out of those 3 are going to get some of this 50? This plant has 50 tons available. Out of those 3 customers, I'm drawing lines right now. That's what that motion is. That motion's drawing lines, arrows. Which one of these 3 customers are going to get part of that 50 tons? So where's it coming from and where's it going to? In order for the company to keep the shipping cost as low as possible. That's what almost all these are about. How to keep our cost down. Before the 1980s, by the way, companies were wasting thousands of dollars on shipping by not having somebody coordinate everything and try to minimize the cost. It was like, let's just get our goods to the customers. And unless they were huge, we could afford to say, oh, let's look into this. Oh, we can do this and figure out how to make this less expensive and save a ton of money. Here's our cost. This is plant 1, plant 2 of ours. We're Acme. Here's our 3 customers. Now, back in the old days, and you got to understand this, so you can see what's happening when we put this on Excel, what's going on. We always drew networks out using nodes and arcs. Now, here's one of those things you got to write down. Now, those first 3 models, and really all 5 of them, every node is a constraint. Everybody hear that? So when you look at, if you're given a drawing of a network model, and the question says, how many constraints will this network problem have? You just have to count the nodes. That's how easy that is. The nodes are these little round circles. Oh, hang on. I got a book right here. Chapter 6. What is going on? Going the wrong way. There. Well, let me get one that's transportation. Okay, right down here. Come on, where is it? Did I just do that? Okay, right there. These are nodes. You ready? Quiz question. How many constraints are there for this network model?
7.
Oh, it's that easy. Okay, you ready? What I want you to also write down is if you got this down in big where you have it in front of you when you get to these questions, every arc is a variable. This makes it so much easier. You know exactly how many variables there should be. You know exactly how many constraints there could be. You know these little rules that I make up. I think that I can't find it on the PowerPoint. So I have 7 constraints, you said. How many variables will there be? 6. Every arc is a variable. There's 6 variables. Now, in network models, we've always used to use, and the PowerPoint still do, x's with numbers below the x, like that. And what this means is it represents an arc, because every arc is a variable, and the numbers are where this arc's coming from and where the arc is going to. And those numbers represent the number of the nodes. They all get numbered. So if I were to write this arc right there as a variable, it would be x what? 2. That's right. And if you get the hang of this, every time you look at a variable, x3, 1, you know it's talking about going from node 3 from 2, 1, node 1.
They would normally all have different numbers?
Not in transportation, but in transshipment, you have to make them all different numbers. In assignment, you don't either. The reason in transshipment is because if you have 3 nodes, or like this, kind of, you have these center nodes. So if you go 1, 2, 1, 2, 1, 2, 3, and you say x11, you can't tell if you're talking about from here to here or here to here. So you have, in transshipment, you got to number all the nodes different numbers. But in assignment and transportation, the left-hand side starts at 1 and goes to whatever, then the right-hand side starts at 1. They can be the same number, because you don't have a third component involved. All right, so there's that. Now that we got those down, let's keep going on this problem. Oh, almost forgot. But there's another thing. See those numbers, 24, 30, 40, those costs? If this were drawn up, the costs go on the arc, because it represents the cost going from one node to another, and the costs are on the arcs. Sometimes, most of the time it's cost, sometimes it could be time. Whatever it is you're trying to minimize or max, that's what's on the arcs. And usually it's a cost. And usually these are all usually minimized, but not necessarily, but usually. Okay. Now that we got that, let's draw this one out. You ready? How many nodes will be on the left? How many? Say it again. 2, because we have what? 2 flanks. Exactly. Here we go. I'll number them 1 and 2. Now, on the outside of my nodes for transportation, that where things are coming from, you put the amount of goods that could be shipped from there, which was in the story. How each of our plants could provide how many tons?
50.
50 each. I put 50 on the outside of this one, 50 on the outside of that one. What I just wrote there, this 50 and 50, is the most common mistake every single semester on the next quiz you're about to have, leaving this off if you're asked to draw a network. Almost everybody leaves this off. And on the other side, how many customers do we have? 1, 2, 3, 1, 2, 3. Just to put names out here, this is Northwood, this is Westwood, this is Eastwood, and this is plant 1 and 2. On the outside of the receiving nodes is how many they ordered, how many needs to get to them. So in the case, I don't remember the exact amount.
25, 45.
25 on this one?
Yeah.
45 you said?
Yeah.
And what's left?
10.
10? All right. That's now. Are you ready? This is one of those, again, you're going to write down. The receiving nodes are almost always the customers, and we must fill their orders. We must do everything we can to fill their orders, and so those nodes are almost always equal signs. Not less than equal, not greater than equal, but equal. So let me repeat that, because this is one of those little rules that will make this fast for you. The receiving nodes in transportation is usually our customers. And their orders must be filled, and it's represented by writing the constraints as equal signs, meaning wherever the goods are coming from, we're getting 45 tons to customer 2, west side. We're getting 25 tons to north side, and we're getting 10 tons. All right? So those are all equal signs. Usually, unless it's special circumstances, where goods are coming from, especially when it's obvious there's more than what's needed, these constraints are almost always written as less than equal. Because we don't have to ship all 100 tons. We have the capacity to make 100 tons, but we're only going to maybe make 80 tons, and we may only ship 80 tons. Unless there's a savings in making more than the 80 and inventorying it. If there's a savings involved, we'll go and make more. As long as we don't have to go into overtime, there may be a savings. All right, now I look at this. If there were a blank right here or a 0, that means plant 2 cannot ship to Northwood, and they don't get an ARC. But if there's numbers there showing you the cost, if you were to ship it from this to that means an ARC needs to exist. So in this case, how many ARCs do you see there?
6.
6 ARCs. Help me out. 1 to what? Where should I go with the first ARC? 1 to 1 right there, and you put an arrow. And on this ARC, I got to put the cost going from plant 1 to customer number 1, Northwood. And what will that cost be?
24.
There you go. Let's go to the right. Plant 1 to Westwood, it says. So I go that, and the cost is 30. Is that correct? Plant 1 to Eastwood, and the cost is 40. So there's those 3. Let's go plant 2 now to Northwood, and that cost is 30. And this one's going to Westwood, and that cost is 40. And this one's going to Eastwood, and that cost is 42. Boy, it looks like it's a lot less expensive to be shipping from our first plant than our second plant. We'll probably want to ship as many as we can from our first plant. And you could almost figure this out yourself. But you got to remember, in real life, you don't just have 2 nodes and 3 nodes and only 6 ARCs. You probably got a much bigger thing, and you're relying on a software solver because it's not something you're just doing in your head really fast because it's never this small. All right, you ready? Ready to write constraints? How many constraints am I writing again? That's right. I have read nodes constraint. Go ahead.
Where's the 25, 45, and 10 come from again?
Where's that at?
That was on the
The
That's
original,
demand.
the
Hang on.
original problem.
Yeah, that's
Right here says we have 80 tons to schedule for the week.
Okay.
25 tons goes up, the 80 goes there, 45 goes there, and 10 goes there. So, and then, I'm not going to the next slide. The next slide is the answer. I'm going to turn all of this now into an objective functioning constraint. Define my variables. I'll write x1. All x's are the arcs. How's that? I don't know what. You don't have to define your variable on this one. How's that? You ready? Which constraint? Let's start with this constraint. First of all, I said it was going to be either a less than equal, greater than equal, or equal for these constraints. What did I say? Less than equal. Less than equal, less than equal. The right side is how much it could supply, which is how much for the first node.
50.
50. Second node.
50.
There's the right side. I want to do the right side of these 3 since we're already at it. I said on the receiving end of these networks, the constraints are always equal. So I'm going to go equal, this one's what, 25, equals 45, equals 10. Okay, this is one of those times now. When you write the constraint for a node, the key is to look at every arc that touches that node. Everybody hear that? Because every arc that touches that node is the variables that need to be added up to either be less than equal or equal to the right side. So how many variables are going to be in my first constraint for that first node?
3.
What? Oh yeah, okay, there's 3. I thought there's only 2. 3. So
Give me a heart
3
attack.
variables.
I was like, what?
Help me out. I got to put 3 variables here added together. Do not use these numbers. Again, that's the second most common mistake. Do not. These costs are all about your objective function, not your constraints. Your constraints are just variables in these transportation models. You ready? Three constraints, help me out. I told you how to write these variables. I'm sorry, three variables in this one constraint. I told you how to write them out. Help me out. X, 1 plus X, 1 2 plus X, 1 3, less than or equal to 50. That's how easy this is. You could write this whole thing. I don't even know why I'm still lecturing. I don't know what's going on. Second one is this node. How many arcs are touching it?
Three.
So it's going to be three variables. Same logic. Ready? X, 2 1 plus X, 2 2 plus X, 2 3. Yes, Sean. That's the advantage of showing up a little early. You ready?
I have friends now.
Okay, that's what you think. Are you ready? This is equals 25. How many arcs are touching it? Two. Two variables then. I gotta look at what they are. Okay, here we go. X, 1 1 plus X, 2 1. This is if you're catching yourself going too fast, this is how you catch yourself. If the nodes on the left, the first number will always be consistent. 1 1 1 2 2 2. If the node's on the right, the second digit will be the one that's consistent. Everybody hear that? So if the node's on the left-hand number is the one that's consistent. If the node's on the right-hand number is consistent. And that's how you catch yourself if you're going too fast. One of those little tricks again. I didn't see everybody writing down, but that's okay because you can watch this and write it down later. And this is true for all of these. That's why I'm giving you these big hints. Because you're going to apply this to all these and make these easy. I'm going to try to make chapter 6 so easy that all you got to do is spend time on 4. There's the quiz.
Thanks.
I'm trying. All right. Help me out with this second receiving node. 2 arcs, 2 variables. X.
1 2.
1 2 plus X.
2 2.
2 and 2. The right-hand numbers are consistent. 2 arcs on the last one. So this is X. 1 3 plus X.
2 3.
2 3. There. I know they're not lined up, but there are our 5 constraints because we have 5 of those. There's our variables that are being used. And now that you're almost done with this problem, that's how easy it is. The last little part is the objective function, and this is where you use every variable, and we know exactly how many variables we're supposed to have in this objective function because we just count the arcs. So there's 5 variables, but this time you have all the variables added together, but you put that cost that's on every arc or on this you're going to get a bunch of these little tables with all the costs on them with the variable, and then you're either maximize or minimize, and most, I'd say 90% of transportation models are minimizing. So I'm going to start out with, you ready? I got room for all the variables here? Put it up here. Min. You ready? The first one is a 24, X, 1 1 plus 30, X, 1 2 plus 40. You guys getting this? Help me with the next one then. What's the next one here? No one knows where I left off.
30.
What'd you say? 30. 30 X
2 1.
2 1 plus
40.
40 X
2 2.
2 2. The last one is
42.
42 X
2 3.
2 3. There's your objective function. And when I grade these, I just look at it and say, do they, odds are you have it correct. If I go, oh, it's supposed to have 6 variables. 1, 2, 3, 4, 5, 6. They didn't miss one. The reason it's a big deal is because when we get to shortest route, it gets a little more difficult. Only because arcs can go more than one direction. And on these transportation, assignment, and transshipment miles, arcs only go one way. So you know exactly how many variables you have by just counting the arcs.
So instead of using just one of these tables, that just correlates to the arrows, right?
Here's the thing, you don't know if you're going to be asked to write the objective function and constraints, you don't know if you're going to be asked to write the network, and you don't know if you're going to be asked to write whatever you have to write from the story or from just the drawing.
So I just have to work out that way.
Well, I want to show you all 3. I wanted to show you how it works out if you've got a story and you're being asked to draw a network, or if you've got a story, you're being asked to draw the constraints and the objective function, or if you don't have a story, you only have a network and being asked to give me the objective function.
Well, right, so like X11 is 24, so you have line 11 is 24. So
That's right. That's right. You don't even have to have the story.
Right.
That's what I'm trying to do here is get you guys so familiar with whether you have the story or you will have this drawing, or you may only have the objective function constraints, and you gotta figure out how to put the drawing together from this. Don't get me wrong, I most likely won't do that. But I'm saying that's how familiar, when you get used to these, you can literally put the whole thing together by looking at this. You know there's an arc, 1, 1, 1, 2, 1, 3, oh look at that, there must be 3 on the right, 1 on the left, so far. Oh, 2, 1, 2, 2, 2, 3, 3 on the right, 2 on the left now. I mean, you can literally put it, you know exactly what number would go on the arc by just looking at this. That's how logical these really are. You ready? Let me see here. Plant 1, plant 2 can provide 50 tons each, right? 50 is your supply. Here's our 3 destinations it could be shipped to. Here's their orders. 25 for Northwood, 45 for Westwood, 10 for Eastwood, and in the middle are those costs. When you're using Excel to solve this, this is how you set it up at the top. Your objective function right here is going to be the optimal solution. Let me get here for you so you see what I'm saying. The optimal solution is going to be in these cells down here. This is going to tell you, these 6 cells are going to tell you exactly how many tons we need to ship from plant 1 to Northwood. This is going to tell us exactly from plant 1 to Westwood, and so on and so on and so on, right here. And the objective function is taking these numbers times those costs to minimize this total cost. So let's say we're shipping 10 tons from plant 1 to Northwood, times 24 is 240, plus whatever that is, times 30, plus whatever that is, times 40, and so on. So this formula has to be this. But to convert that to that formula, it's the cell location where the optimal solution is going to be, just like those other ones. It just looks a little different. It's the optimal solution times the number. This would be the objective function number, as you can see in the objective function. All added together. Oh, I did it that way, but I used to say, let's see, F7, where's that? F7 times F21 plus G7 times G21 plus, and all that. But that's really what that's doing right there. Everybody got it? So there's that. Now, the formula cells you used to have on the left side of constraints on those previous problems, on these networking problems, those formulas are right here. We have 2 constraints related to the supply of 50 tons that could come out of our plants. There's the 50s, there's less than equals, and here are some calculations adding all of this together to the total amount of tons that we're going to be shipping from plant 1. All of plant 2 added together, it's got to be less than or equal to a 50. That number, that calculation's right there. So you'll see it's the sum. This is adding, what is that, F21 through H21, these 3 right here. This calculation is going to be these 3 here. What? Right there. Now, these constraints, these equal to constraints right here, they're right here. These 2 added together, it's got to be equal to 25. These 2 added together, the total will be right here, and it's got to be equal to 45. These 2 added together, the total will be right there, it's got to equal 10. So that's how you set it up. These are all little formulas. Let me show you right here. Adding these 2 together, this one's going to add these 2, that one's going to add these 2. And here's where you place all your data. It's really a lot like the previous problems we've been doing. The setup's just a little different, but we're using solver just like we use solver on the other ones. We have to tell it that the constraints are down here. And we have to tell it that the objective function's there, and the optimal solution, instead of those zeros across in one row, we want to tell it we want the optimal solution in these 6 cells, right there. Are you ready? By the way, if you're taking a quiz, and this Excel spreadsheet with the solver opens on the quiz, you've already seen that before, I would go to this page that I always put on these, if you look back at the other ones, where it shows you step by step how to do this, if you can't remember it, and what should be in that solver cell, what it is it's referring to. This is posted with those page numbers on there, okay? You ready? Solver, data, solver. First thing is, where's the objective function? Right there at F16. Next, this is a minimize. Where do you want the optimal solution, which is going to be right here, which is F21 all the way over here to H22. F21 all the way to H22. Those 6 cells are where it's going to, what Excel is doing is putting numbers in there so fast to figure out which combination of numbers is the absolute best. Okay. Now the constraints. F23, is that F23? Wait a minute, where am I? F23 through H23 has to be equal to, these are what this is going to add up to, has to be equal to F25 through H25. F23, H23 equals F25 through H25. Instead of you saying it's equal to the left side to the right side, or less than equal or greater than equal, we're taking these bottom calculations and comparing them to what we want to be shipped to each customer with equal signs. Now, the next constraint are, where's our calculation? These two calculations, what is that, I-21 through I-22, is that I-21, 22? Compared to those two 50s that are right out here, which is at K21 and K22. Everybody see it? This is posted. So and I think when you open it up, you'll see that those are all in there the correct way. Make sure that box checked. Make sure you've got simplex LP. Then hit solve. Then say OK. What you're going to find now, well, the optimal solution is going to be all in there. And then you've got to be able to read that output and answer questions such as, how much are we shipping from our first production plant to our customer at Northwood? 5 tons, that's right. They just made me frown. It doesn't take much, does it? Are we shipping exactly 45 tons to our second customer? And if so, from one location or 2 locations? One location. We are. All 45 tons are only coming from plant 1, and they're getting all 45. Notice 45 exactly is being shipped to that second customer. 10 is being shipped exactly to that third customer. 25 is being shipped to that customer. This is the only one that's getting it from 2 different locations. Plant 1, trucks going straight there, and plant 2, trucks going there, and no other, and then this one has 2 trucks coming. And this is the least expensive combination way of delivering these goods than any other way. Matter of fact, there probably could be an alternative optimal solution, but there is no way to get the cost down, not even a penny. What's the lowest we can get the cost of getting these goods for this week to those 3 customers?
$24.90.
That's right, $2,490 is what it's going to cost for the week in shipments. And there's no other way to get that down based on the information. And so you might as well go with this one, even though there might be an alternative. Why spend all the time finding an alternative when there's no way to get that any lower? That's it. That's as low as it gets. And that's how you don't waste money. You ready for the next one? All right, what's next? Assignment? Wait, here's our answer. Well, did we have 5 going to Northwood? Oh, okay, we have both plants going to Northwood, 20 and 5. 1 plant going to Westwood with 45, the other plant going to Eastwood with 10. There's our total cost for each shipment that's going out, wherever it may be going. We're skipping this one. We're going to assignment. Okay. Before I start assignment, I want to refresh what I said about it. I can almost turn this into assignment. Are you ready? Everybody erase it. Boy, I can even almost leave all of this. Almost. Hang on. Let's start from scratch. All right, hang on. Here we go. You ready? Here's how I turn this into assignment from transportation. All I had to do. This isn't this problem. This is where I just want to show you the difference between transportation and assignment. Did you notice what the difference was? Just how much could be supplied and how much is in demand. That's the only difference. And this problem will read that, hey, we've got 2 people available for these 3 jobs or something like that, you know, and 1 to 1. Now, think about the little hints or rules I told you about writing constraints and the objective function. All the same. Nothing changes. So if first of all, in this one, even though it's not the problem we're talking about, in this one, how many constraints would I have? 5 constraints. How many variables would I have? 6. Don't forget what I said about which nodes are less than or greater than or equal. Are you ready? If I were writing a constraint for this node right here, would it be less than equal, greater than equal, or equal to? Less than equal to what? 1. That's right. Just like transportation, but instead of 50, it's just a 1. So node 1, less than equal 1. Node 2, less than equal 1. What about these 3 nodes? What did I say were the rules about these 3 constraints? All equal. But instead, equal to what?
1.
Equal 1, equal 1, equal 1. That's the difference between assignment and transportation. Everything else is the same. I would have my variables with no numbers. These numbers could be how many hours are available, or how much we have to reimburse, or something like that. And they're either going to be minimized or maximized, and in most cases, it represents something you want minimized. And so that's your objective function, is every one of these variables with that min, just like transportation. And here, you do not put these numbers in the constraint, just like transportation, just the variables. And however many arcs you're touching that first node, that's how many variables would be in this constraint. So in this hypothetical example, let's write this first constraint. How many variables should I have?
3.
3. X, 1, 1 plus X, 1, 2 plus X. It almost looks exactly like transportation, except for the right-hand side. Boy, did I make this easy. Man. That's it. We're done. Okay, you ready? Now get rid of this one. This was hypothetical. All right, hang on. What's our story? You looked at all this when you were at home. What's our story? You ready? You're a general contractor. You're working for this construction company. You are kind of worked your way up to where you're overseeing several projects, not just one project. And you work with a lot of subcontractors. And you happen to have, is this tomorrow, today? You have these 3 projects, A, B, and C. And right now, you got to schedule some electrical contractors, I believe. There are 3 electrical jobs for tomorrow that we're trying to get all set up. You have 4 electrical subcontractors that you usually work with, but there's only 3 jobs. You got to figure out which ones you're going to assign to the jobs, and the numbers represent the number of miles, because the deal is whichever subcontractor you pick to the project you assign them to, you have to reimburse them a certain amount of money. Let's say it's a lot, but for the amount of miles they have to drive. So your objective is to keep that cost as low as possible. Max or min? Min. The numbers would be the miles, because that's what's given to you, and those numbers would be what's on each of the arcs. How many arcs are there? 12 arcs, because you see 12 numbers. If I didn't have, let's get this drawn so you can see the big picture. Sean, are you ready? Because I know you know this. How many nodes will I have on the left side that of I'm going to give it away. Shoot.
4.
How many? That's right. How many? 4, right? 4. 1, 2, 3, 4. 1, 2, 3, 4. This is assignment. You just number them from 1 down. I'm going to put this is west side, this is federated, this is divided, this is universal. I got to put my supply numbers on the outside. What do I put here? 1. Only one subcontractor could go to 1 project. That's why we're using assignment. That's kind of the big hint. And then, anybody, tell me how many nodes on the right?
3.
3 for 1 for each project. We number it 1, 2, 3. We start at 1 again because we only have 2 sets of nodes. It's when we get that 3rd set that we can't number this way. Every node has to have a different number if there's a 3rd set. Here we go. What's on the outside as our demand?
1.
1s. We just need 1 subcontractor to go to each project. It's obvious that one of the subcontractors aren't going to get a gig. And it's the one that would cost us the most money to be able to assign. And I know you're looking at this going, we need Universal to go to C, but if it causes us to spend extra money sending someone else to B or A, this may not be the obvious part. And that's where the math comes in. Are you ready? At this point in time, can this subcontractor, west side, go to any one of those three projects.
Yes.
So you would have an arc going to each one. If my question I just asked is no, is if West Side had a 0 or a blank on any of these numbers, is trying to tell you West Side cannot go to that project if there's a 0 or no number there. And so you would not put an arc.
Zero.
And you would not have a variable. Say it again.
I said 0 doesn't mean it's 3.
Means they won't show up. That's a 0. So if I kept going, we have all those arcs. All right. Let's write. Oh yeah. On these top arcs, what number goes here? 50. What number goes on the next one?
36.
What's the next one? 16. Do I need to write all these out? Or you get the gist? You got it all? I just want to make sure. How many arcs are going to come out of this fourth node right here?
3.
Good point. 3. And what numbers? Just make sure. Hang on. What number would be on the top one? 25. The second one. Oh yeah. And the last one. 14. You getting this? All right. Let's do the objective function then. Let's just jump into it. Max or min?
Min.
Min. Okay. What's my first number? 50 times x. 1. Right? 50 is going from subcontractor 1, possibly going to project 1. Plus, what's that? 36 times x. 1, 2. Going from West Side to possibly go to project B. Hang on, this is project B, this is project A, this is project C. Plus 16 times x, 1, 3. Plus, help me out, 28 times x, 2, 1. Plus 30 times x, 2, 2. Plus 18 times x, 2, 3. And then 35 times x, 3, 1. 32 times x, 3, 2. 20 times x, 3, 3, right? Losing track of it. 25 times x, 4, 1. Very good. 25 times x, 4, 2. 14 times x, 4, 3. There's our objective function. Let's do one subcontractor constraint to make sure we got this. All right. You ready? Gabe, help me out. You ready?
I know you've seen Doug.
Just checking. At least you admitted it. You ready? We're doing node 4 right here. Less than equal, greater than equal, or equal?
Less than equal.
Less than equal to 1. How many variables should be in that constraint for this node right here?
3.
3 variables without the numbers. I'm telling you, I know I'm emphasizing this, and somebody's going to put the numbers on there. It happens every semester. Well, I would throw a pump. Just kidding. You ready? Okay, give me the variables since there's only 3. X,
4,
1 plus x, 4, 2 plus x, 4, 3 less than equal to 1, because we don't have to assign the subcontractor one of the projects. It may possibly be the one that doesn't get assigned, or we could assign it. That's why it's less than equal. Now, I'm not going to trick you, but in real life, if we have less on the left that could go to projects than the number of projects, you have to add a dummy agent, it's called, because it will not be solvable using any software or Excel unless you have an even amount or more, what did I just say? Agents or subcontractors, agents, compared to the task. Everybody get that? Transportation, you can have just 2 warehouses shipping out, or just 1 factory even. But an assignment model, you try to do this with, like, let's say we have 2 here and 3 here, it will say unsolvable. You've got to add what's called a dummy, which would be, I think is a 0. The constraint then would be a less than equal 0. I'm not going there. You guys got enough to handle. I'm just making sure you introduce it to you because I know you've read it on the PowerPoint before you came to class today. And I want to make sure you understood what it meant. All right? Making sure. All right. Here we go. This is the first time we haven't used this in a long time. Yeah? Hang on, I'm not taking that shortcut. I'm going linear programming. He's trying to jump ahead. There we go. Open We're in chapter 4, what was that called? Where's the assignment? Right here, right? From 2014, all right. Look at what I did. I took the objective function. First of all, I said it has, how many variables was it? 12. 12 variables, and it had like x1 through 12. I went up and changed the numbers to these numbers, x11, x12, x13, all the way across. And then the numbers in the objective function are the numbers we put here, the 50, the 36, all these costs. Down here are nothing but ones. If we were using the software on transportation instead of Excel, these would all be ones, even on, I don't even know what I'm saying, on Excel. Keeps going, notice, let's find this one. If we did this right, when we find this one, there should be a 1 underneath x41, a 1 under x42, and a 1 under x43, and the right-hand side should be a 1, and all of them are going to be 1s, right? Let's find the right, see, we can't even see the right side.
Let's scroll about halfway up.
Oh, thank you. There. See how they're all 1. So which constraint is this right here? Constraint 1, 2, 3, 4, 5, 6, 7. No, because this is not an equal. But I appreciate you taking the lead. I appreciate
I'm
it.
confident about it.
I know. I know. I appreciate it. Help me out. Which constraint? 4. Right there. Is there a 1 underneath x41? Is there a 1 x42? A 1 under x43? It's a less than 1. And that's how that constraint would be entered. Any of these constraints, you just put 1s underneath the variables being used for that constraint. We got that all entered now, right? Objective function, the constraints, we change the variable names. We got the right-hand side, we go solution, solve. Before I hit solve, I gotta make sure I know what I'm gonna ask you. Okay. Where is subcontractor 2 going? Which project is contractor 2 going? What project?
The first one.
What? Wait, no way. Subcontractor 2 is, yeah, you're right. I saw that. You're right. Do you see what he did? I said subcontractor number 2, which represents the first number with the variable, going to project, I said which project is that person going to, so you had to find an x2 something that has a 1, because the 1 represents that that's what's happening. Zeros mean this is not happening. You get it? So x21 has a 1 there. It means subcontractor number 2 is going to project 1, which is project A. Who gets to go to project C? Who was only $14? Was that subcontractor 4?
Yep.
Is contractor 4 going to project 3?
No.
No.
What? Well, who gets project 3 then?
First one.
Contractor 1, the third one down, is going to project 3. And who is not getting a job? Which subcontractor is left in the cold for tomorrow?
3.
That's right. 3, 1, 3, 2, 3, 3 are all zeros, not assigned anywhere. This is the lowest we're going to be able to get our mileage. There could be an alternative assignment, and one's our brother-in-law, so we got to assign him and let someone else not get a job. But we cannot get this cost any lower. The mileage that we have to reimburse, and it happens to be how much? How many miles? You got it. The objective function value will always be that thing we're trying to minimize or maximize. In this case, it was the miles, 69 miles. All right? You can read this, right? Should I keep going? Yeah. As far as I'm going to test you, I'm not going to say, okay. I mean, I could say which constraints are binding. I mean, it's just so easy. I could throw that in there for an easy 2 points, maybe. Or not. Oh, shoot. Anyway, somebody's going to tell me real quick. Which constraints are binding?
All of them except for 3.
There you go. Everybody hear that? Was that Henry? Was it Casey? All right. Everybody hear him? How did he know all of them but 3 is a binding constraint? That's right. Binding constraints have 0 slack or surplus. And real quick, is that 0 slack or surplus?
Can't tell from
Zero
there.
slash.
That's right. That's right. Because that's constraint number 4, which happens to be this one, which happens to be the one we did, and it's a less than equal, which makes it slip. Real quick, shortcut. Ready? Change modules. You just want to get the answer real quick. Click on the assignment problem. instead of linear programming. You don't have to, if the problem says, I don't want the objective function, I don't want the constraints, I just want the answer, what's the best way to do this? This is the module you use. Hang on, I know I did it. Which one is it? Is this it? Right here. When you set it up, it's going to say how many these aren't agent nodes are in the problem. You're going to say 4. How many tasks are in the problem? You say 3. It will open this up, and all it wants you to do is put in the objective function numbers for each of the variables. x11, 50. x12, 36, 16. You don't have to put all those ones. You don't have to put all the objective function. Just this grid. Once you tell it how many nodes on the left, how many nodes on the right. Now, we hit solve. The answer looks a little different. I'm going to ask the same question. I can't remember what the question was. Which subcontractor gets project C? Right? Is that what it was? You ready? Well, hang on. This Min?
Yes.
Which subcontractor gets project C, which was project number 3?
One is 3.
Agent 1. So it's a lot easier to read this one almost, isn't it? Agent 1, West, whatever they're called, is going to go to project C. And Agent 2 is going to project 1 or project A. Agent 1, whoops, hang on, Agent 4, excuse me, is going to project 2. And 3 doesn't get a deal. Is that right? Is that the same answer if we did it the other way?
Yes.
What about our total miles? We're trying to keep as low as possible. What does it say here? The total is
69.
Same answer there also, right? All right, we got one more. How are we doing on time? Barely. Transshipment. Oh, hey, look at this. Here's our objective function. Here's our less than equal to still the subcontractors. I didn't realize it's here's our task is equal to. Here's the variables. Blah blah blah. You guys don't care now. This is too easy. You don't need to see this. All right. This is what transshipment looks like. The story will say, hey, we have goods that could come from these 2 plants, and we've got 2 customers that need orders right away, but we ship to these distribution centers who will fill the orders for us. Got it? The story will say something like that. It's going from this city to this city, then they're splitting it up, and they're sending it to these cities. Something like that. And when you see, as you're reading it, and it says, stuff is being shipped somewhere, and then it goes on to somewhere else, your mind should go straight to, oh, that's transshipment. It's that middle stop that gives it away. Now, the deal is, you, like I said several times, I want to make sure you get this. You have to make every node a different number. You can't do the 1, 2, 1, 2, 3, 1, 2. Again, because x11 could be here to here or here to here, and it just doesn't make sense. But if you use separate numbers for every node, I could say x35, and you know I'm talking about this first distribution center. No, I won't say 35. 36 I meant. And you know I'm talking about the first distribution center over here to the first customer. 36. 1, 5. 1, 4. And if for some reason the story doesn't give you some kind of cost or miles or whatever for going from one place to another, that arc should not be there. And if for some reason you put an arc there, you've got to have a 0 on top of that arc, because that means there's really nothing being shipped here. And you really even shouldn't have a 0 for it. The arc shouldn't even exist. Now, when we read the story, it's all about you telling me how many nodes on the left, how many nodes in the center, how many nodes on the right, and we'll draw this out. Then the logic, I'll show you the logic, is very similar, almost exact to the logic on these assignment and transportation until you get to these. Same rules. How many constraints, by the way? 7. Matt, thank you. How many variables? I think I got to think. How many variables? 12. Every arc is a variable. It's that easy. For these first 3 models, it's that easy. You stop there. Okay? Because we're heading to next week where some of the arcs go more than one direction, so it represents 2 variables. This arc we're heading into on Tuesday, there could be an x24 and an x42. So that's where we're heading. But for right now, these first three models, every arc goes one way, and it represents one variable. It only goes one way, from beginning to the end. All right, here's the story. The north side and south side facilities at Xeron Industries, that's us. Just I'm telling you, the keys to these, you gotta zip that imagination. That's how I find it easy to come up with what the decision variables are. I literally imagine that this is really something I have to do. And then all of a sudden it dawns on me, oh, what about this? What about this? And then I realize what decisions have to be made. You've got to get that imagination as you're reading this. And I want you to picture that you're Xeron. Are you the supplier? Are you the distribution center? Are you the customer? But you're Xeron. You ready? The north side and south side facilities of Xeron. How many facilities do we have?
2.
Okay, you're with me so far. Supplies 3 firms, Xerox, Hughes, Wright, Rockwright. There's possibly 3 nodes there. We don't know where yet. With customized shelving for its offices. Okay, that's our job. We provide these shelvings for offices, these customers. Says they both of our facilities order shelves from the same 2 manufacturers, Arnold and Super Shelf. Where are we in the big picture?
On your left.
In the middle. We're the middle. We're getting it from the manufacturer. We're taking them then to our customers after we maybe customize it somehow. Get it? That's what makes it transshipment. As you're reading these, you got to say, wait a minute, it's coming from us to somewhere, but we're getting it from somewhere. That's where the 3 comes in and it clicks. Transshipment. Okay, let's start here. On the left is where it's originally coming from. How many nodes on the left? Sean, hang in there. Because I understand. Why say 2?
Because of Arnold and Super Shelf.
That's right. The manufacturers are where it's originally coming from. And there's only 2 of them. And this is 1, this is 2, and this is Arnold and Super Shelf. What goes on the outside in this particular problem? No, not 1. Matter of fact, I didn't read it yet, did I? It says, currently, weekly demands by the users are 50 for Xerox, so this is going to be a weekly thing. We're planning our week. 60 for Hughes, 40 for Rockwright. What is Xerox, Hughes, and Rockwright? Where are they at in this big picture? Not in the middle. On the right, they're the customers. We're the middle.
Oh,
We're ordering it, we're taking these shelves, we're doing something to them, and then we get into the customers and install them. Over here, how many nodes do I have on the right then?
3.
3. Okay, I'm not going to number them yet, but this one is Z, right? Xerox. And how many do they want? 50. And then this is Hugh, and they want 60. And this is Rock, and they want how many? 40. You've got to have these numbers on the outside. What could be supplied, which we're about to read. Both Arnold and Super Shelf can supply at most 75 units. What number goes here on Arnold? 75. What goes on Super Shelf?
75.
You got it. Okay, that's where we're at so far. We've got it all covered, except we haven't numbered things. Wait, you told me that this is us. How many locations do we have?
2.
There we go. Now we can number. 1, 2, 3, 4. This is our north side. This is our south side. 5, 6, 7. How many constraints will we have? That's right. We need to see if we have the availability to go to all customers, if we have the availability to receive them from both suppliers, or only our north side can get it from one supplier and our south side can get it the other. So we go on to this slide which says, here are the unit costs. The costs if you are getting it from one of our manufacturers and it has to go to one of our 2 locations. Then, after we do our thing, and it goes from one of our 2 locations to one of our customers, here's the costs involved. Costs. Is this a max or a min? It's a min. How many arcs will there be? I see 10. I think. I got to count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You ready? Let's start with Arnold. Can it go to either one of our locations?
Yep.
Okay, here we go. What about Super Shelf? Can they deliver to either one of our locations?
Yes.
All right, there we go. What number do I, if we order from Arnold from our northern location, what's the cost per unit here? 5. What if we order from our southern location from Arnold? 8, very good. Northern location from Super Show? 7, and southern location? All right. Here, from our northern and southern location, can both of them go to any one of these 3 customers, or is there something telling you that maybe we can't deliver to one of these from our southern location? They all can go anywhere from anywhere, right? So I have 1, 2, 3 there, 1, 2, 3 there, and if everything's done right, there should be 10 arcs there. Is there 10 there? Everything's done right? Help me with the numbers here. Going from our northern location to our customer, it starts with a Z, Xerox. 1. From our northern location to Hughes, is that 5? 5, and from our northern location to the Rock, right? 8. Now, southern location, that's a 3, that's a 4, that's a 4. Got all our numbers on there, right? Okay, are you ready? Do you remember from the other 2 that constraints coming from somewhere are always, what kind of constraints? Less than equal, equal, or greater than equal? Less than equal 75. Less than equal 75, right? So there's the right side of our supply. Okay, before I do the middle ones, I want to do these, because I want to stay with the logic you learned already. Our customers, their constraints when they're written are always what? Equal. Equals 50, equals 60, equals 40. And these 5 constraints are just like transportation, and just like assignment, in that if there's an arc touching the node, then that's a variable, and you don't use those numbers, because those numbers are the objective function, not the constraints. So how many variables would be in this less than equals 75 right here, the top one representing Arnold? 2. Give me the variables. X, 1,
3.
no, 3, because we had to use different numbers. Yeah. 1, 3, plus X, 1, 4. Let's jump to our first customer. How many arcs are touching that customer's node? 2 arcs? All right, give me them. X, 3, 5. Whoop, whoop, hang on. 3, 5 plus X, 4, 5. You're getting this. Just want to make sure, we're going to the last customer. I want to make sure you're getting this. How many variables would be on this last customer here? 2 variables. X, 4, 7. Wait. Yeah, 4, 7. X.
3, 6.
Oh, I'm sorry. That's twice. Glad we're not, glad there's no extra credit. All right. So we wrote all these, right? These are these 2, these 3. Am I running out of time? You guys give me looks. You ready? The middle nodes. This is the hardest part of transshipment. So you need to write a little note on this one. On transshipment, the middle nodes are always equal to 0. It's only transshipment you have this situation. Transshipment, these middle nodes, these constraints for these middle nodes are always equal to 0. Now, the reason why, you don't have to write this down, but the reason why is, in distribution centers, everything that gets shipped to it gets shipped back out. They're not a warehouse, they're not a storage center, they're a distribution center. Their whole thing, when distribution centers were invented, it was like, okay, we'll order and get the big discount, a whole bunch. But then we have all these other ones that want that, so we'll split it up and we'll sell it at a markup to all of our customers that need it, and then they sell it to the end user. So that's how they work. But they order exactly what they can sell. They don't hang on to it because it'd just be a loss of money. So that's why this one's going to be equal to 0, because whatever goes in has to back out, and that one's got to be equal to 0. Okay. Now, I'll make sure everybody hears this part. I don't know what I got to do. When you write the middle node constraints, you have to make the variables going in either positive or negative, and the variables going out of that node the opposite. And if you decide to make the ones coming in positive, then all the middle nodes have to have the variables coming into them positive. You have to have consistency. You can go either direction, negative to positive or positive to negative, but they must be consistent for every middle node. So let's do one. I'm going to do this top one first, and let's make whatever's going in positive. So My question for you is, on this little node equals 0. We know that. My question is, how many variables will be in this constraint? 5. Very good. I'm looking over this direction because I know it came out. Very, very good. 5. Because you got to look at the arcs that are touching that node one direction and the arcs touching the node the other direction. And there's 5 arcs touching that one. 1, 2, 3, 4, 5. As sloppy as that is, there's 5. All right? Now we're going to make the ones coming into the node positive. Here we go. X 1, 3 plus X 2, 3, and that's it, right? Now make the ones leaving the node the opposite of whatever you made the ones coming in. So minus X 3, 5 minus X 3, 6 minus X equals 0. And when we do another center node now, because we make the ones going in positive and the ones going out negative, we must make the ones going in positive and the ones going out negative to have consistency, or it won't work. The person next to you could have made these negative, negative, then positive, 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 which will still work as long as every middle node has negative going in and positive going out. The consistency is the key. But you could go pick either way. You ready to do node 2? Or node 4, I'm sorry. Node 4 equals 0. So this is a negative x14 minus x24. Where is everyone? Is anybody here? Okay. Where were you? You let me get past like 2 of these before anybody said anything. I had to stop. X positive x14 because it's going in, and we already went in with a positive there. We have to have consistency. x14 plus x24 minus x45 minus x
4, 6,
minus x
4, 7.
equals 0. Now that's all the 5 constraints. The objective function. Again, how many variables do we have? 10. 10 I got counted, darn it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The objective function will have all 10 variables. They're all just regular, all added together, but with the numbers on them. These numbers, for all 3 of these today, have always been the objective function numbers. None of these constraints are using any of these numbers on the arcs, only the objective function, and that's consistent with all 3 of these you've learned today. Do I need to do the objective function real quick? Everybody got it? Wait, I think it's on here. Here we go. Does ours look like this? 75, 75, 40, 60, 50. Do we have 10 arcs there? Our numbers match up? Let's look at the objective function. What are we at here? Minimize 5x13, 8x14, 7x23, da-da-da-da, all 10 variables. Got it? Our constraints. Here are the ones coming from the far left, where we're originally coming from, less than equal to 75. Here are our middle nodes. Look at that. The ones going in were positive. The ones leaving negative. We have consistency on the other middle node, going in, going out. Here's our 3 customers. My question for you is, how many are we going to order from Super Shelf to our southern location? How much time do you need before I flip this? You ready? I'll say it again. How many are being shipped from Super Shelf to our southern location? I got to think a minute. Okay, how many? What?
75.
75, because I said Super Shelf, which is node 2, going to our southern location, which is node 4. So you jump over here to x24, and you go, oh, 75 are being shipped from that Super Shelf. Hang on, I know you're packing up, but I want to make sure you get this. Once we get the shelves to our southern location, how many are going to go from our southern location to our customer Hugh? From our, huh?
35.
That's right. Our southern location is number 4. Customer Hugh is number 6. X46, 35 of them are going to go from our southern location to that customer. Very good. You can read this. What's the lowest we're going to get our cost to get these all ordered, shipped to us, then do what we have to do, and then get them to the customers? Our total cost is going to be what? 1,150, and that's the lowest we can get. I mean, there may be a different combination to do this, but it's not going to save us any money. Let's run with this one. I'm ordering 75. I'm ordering 75. Get them. Get them. Matter of fact, look at Look at Arnold, you only have one place to drop it off. Look at Super Shelf, you only have one place to drop it off. There they all are. Okay, we're out of time. See you at your quiz.